Wow, we are live. Hello, everyone, and welcome to our third annual Global Forum, Knowledge Graph Forum 2023. My name is Milan. I am from the marketing team of Ontotext, and it's a pleasure for me to greet you and to welcome you to this special event for us and the whole ecosystem around the knowledge graph. So just very brief intro, what you should expect and how to navigate the portal where you are. So this is the lobby. We advise everyone to share his thoughts on the chat window from the right side. And here is the main stage session where actually the sessions are happening. Here is very brief intro, what you should expect and how to navigate the portal where you are. All right, this was the live session, and here are the partners. So I encourage you to come and visit their virtual booths. You can also meet new friends, new people, new colleagues here in the People tab and create new connections. And during the breaks, during the break session, there will be speed networking. Here it will appear a button for 30 minutes. You can meet new people on a flash meeting. So I encourage you to be active. It's a pleasure for me to welcome you. And of course, you can ask questions during the sessions. There is a special dedicated chat window for every session. Please ask the speakers your specific questions. So now I want to give the stage to our Chief Executive Officer, Atanas Kirakov. Naso, please.
Yeah. So do you see my screen? Okay, wonderful. I'm very happy to welcome everyone to the third Knowledge Graph Forum. We started this back in 2021, and it was like a follow-up from all the changes that came with COVID, and it turned out to be a great initiative, a place where, together with our partners, we want to show you and update you about all the capabilities that we developed, all the solutions that we have to offer, to share wisdom, lessons learned, to invite experts. And I'm very happy to see that we have a growing number of attendees. This year we have more than 1,000 registrants and close to 50 speakers. So enjoy the next 3 days. And I'll start it off with my presentation with the funny title, you can't get to the moon on a bike. The reason why is we've been often criticized that knowledge graphs are too complex. And my quick reply is, yes, they're complex, but rockets are complex too. Still, you can't get to the moon on a bike unless you have one of these very special bikes and you have ET with you. So a lot of one of the themes in this year's issue of the Knowledge Graph Forum is how we actually take advantage of complexity and how enterprises can do this. So I'll start off with this topic, then I'll make an argument of what kind of enterprise-wide graph platform is needed to really help enterprises leverage complexity instead of suffer from it. What is the big picture of this platform? What are the really tough points? What are the choke points in implementing it? And finally, for depending on who you are, what is the best way to start with knowledge graphs and with implementing of a knowledge graph platform? So many people in this audience come from knowledge sciences background, and what you learn very early in the university is that you should your software should use the simplest possible model that can do the job. You know what's that? That's a sundial. right? But if we want to look at it in a more abstract manner, this is actually a model of Earth, a very simple model of the rotation of Earth, which help us serve a single purpose to know what the time is. So you don't need to make a globus rotating something if you have enough sun, and if what you can get this way with daytime accounting of time is enough. It can be as simple as that. That's what we mean by the simplest model. It could be very, very, very simple model of the reality if it gets the job done. And that's in a way a reflection of the so-called Occam's razor principle, which says everything that entities that are not necessary should be cut out, should be removed. You should do everything in the simplest possible way. And I do agree, that's right. And now the question, why the hell, if that's right, we recommend to our customers and we preach and we implement fairly complex data models. So these graph technology and knowledge graphs, they're not the simplest way of dealing with data. So why is that? Uh, well, the reason is that complexity is inherent to the big enterprise, to the global businesses. It's byproduct of growth. The larger the organization, you need more complex. It becomes more complex, and you have to manage, have more employees and more people and more technologies, and serve a growing customer base. And that's not me; that's PricewaterhouseCoopers. So, if we want to dig a little bit deeper into this, growth and globalization and having a bigger and bigger enterprise which do more and more money requires multiple business lines. So you quite often an enterprise starts with one thing that it does well, and then to expand the market they need to add more business lines, which means new tools and new systems, which means more diverse and more siloed data. So there was a study by Harvard Business Review, which said measure that the number of tools and applications deployed within organizations have increased by almost a quarter just in the course of 4, 5, 6 years. And an average organization of like 2,000 employees or more would use internally close to 200 different applications. What to tell about the big ones that we work with, like UBS and JP Morgan Chase? They have thousands of different IT systems and applications. So it becomes a real challenge when you want to put some sort of unified view and be able to analyze the data across these systems, to connect the dots across the different functions and the units of the organization and their specific IT systems. You must do this because as the organization grows, management costs grow because you need deeper hierarchies and more communication and everything. So unless an organization can get some gains, so synergies, economies of scale, cross-selling, it's not going to be competitive to the other big organizations which do this. So connecting the dots is an absolute must for each and every big organization. Business efficiency requires integration. It requires data integration. Now, there is a bit of controversy because everything that helps integration is actually counterproductive for the individual units and IT systems. Most of the operational IT systems, they're developed to serve a single business function. And for this, they use the simplest possible model. So any type of metadata or universal data models would make it more expensive and slower, which reduces time to market, which is a bad thing. So people don't do it when they develop and design their operational IT systems. It is usually done post factum later on, and it is somebody else's problem. And this problem grows bigger and bigger as the organization grows, because you end up with a web of interconnected data technology, processes, whatever, which is getting very, very, very convoluted, very hard to manage, to navigate. And even simple questions like how elements impact each other or whether something is necessary altogether for the business so we can decommission it, those questions become very, very hard to answer. This is confirmed by analysis that shows that complexity hinders business growth. So growth is limited by complexity, data integration complexity. So it is run across hundreds of organizations, close to 1,000 organizations, and 86% of the people say that yes, complexity is an issue, and complexity is actually hindering business growth. So you don't need more justification, but if you deep dive, the function that is most impacted by complexity in a negative way is IT. So that's why, yeah, we're here and we are trying to find a better way of dealing with this complexity. A recent article by some of our colleagues is speaking about the same problem from a slightly different angle. So, for most of the organizations to be competitive, they need to adapt and they need to be able to source the relevant information. And that's why organizations and the big organizations become very, very data driven, to the extent to which big banks are getting closer to information technology businesses, with thousands of people dedicated to this data driven paradigm to help them make decisions quicker and better based on better information. But with this data driven approach and all the diversity, most of these efforts have resulted in tangled web of data integrations and reconciliations across the data silos. And this can cost a lot. This can add up to 40, up to 60% of enterprise annual technology spend. And we call this the bad data tax. And everything that we do here is to help you avoid this tax. So to wrap it up, global businesses need to analyze data across the different systems as some sort of holistic view, because no matter what machine learning or graph algorithms you implement, how fancy you are, you cannot uncover dependencies if the signals are not there. And quite often the signals are spread across multiple systems. Knowledge graphs are designed to be the best thing for analyzing diverse data, all the way from having unified conceptual models, ontologies, schemas, taxonomies, and also globally unique identifiers, which help you get the data interconnected in a very, very quick, swift and transparent way. So at the big picture, we can say that knowledge graphs are meant to lower the entropy in these diverse and very, very convoluted IT ecosystems of the biggest enterprises. On the right, you see a very influential picture from one of our customers, a gentleman by the name of Tony Siu from UBS, who essentially says, data integration, knowledge graphs help organizations be more concise and to keep their IT systems under control, and better structured and isolated to avoid inefficiencies and to avoid risks also. So all this is at the end confirmed by Gartner without all the arguments, but with the conclusion that in another couple of years, graph technologies will be more or less all over the place when we speak about data analytics, and this will be a major next step of adoption to the mainstream markets compared to just a few years ago when only the leaders had their first pilot projects with this technology. Now, what is needed to get an enterprise-wide graph platform that can serve these different use cases in a big enterprise? It should be at a very high level. It should connect the data into a reusable graph to power deep analytics. So it should enable organizations to derive insights from their own disparate and diverse databases, to be able to integrate external knowledge for better interpretation of their own data, and also to be able to integrate data and knowledge extracted from unstructured content from documents. So these are like the very, very high level requirements for such a platform. On the data side, we need to get the so-called data fabric pattern implemented to within the organization, to be able to have marketplaces for data, to have data as product, in order to improve the usability and the quality of the key data assets. And if you want to get a deeper view into data fabric and how they support decentralized data management and data mesh, you should listen to Sumit Paus, our strategic technology director, keynote tomorrow, Wednesday. Now, moving forward, graphs and text analysis, they were dancing together for quite some time. And there was always this complementarity of, you can use text analysis to populate graphs and to enrich graphs, and you can use knowledge graphs as context to improve the performance of your text analysis pipelines. So it was all the time a tango and complementarity. And what this requires back and forth is semantic metadata. So this is the glue. This is what turns knowledge graphs into hubs of data metadata and content within a big enterprise. And this can take many different types of metadata. And of course, it should all be semantic. Because Gartner said it should be semantic. Gartner said that to overcome the silos, you need semantic data models to put the data together and to be able to interpret it and to align data coming from different sources. So what does semantic mean? Semantics is all about having rich descriptions of your data. So you can see the graph on the left. You have two pairs of shoes there, and these two pairs of shoes, they're both sport shoes, different brands. They're somehow related, being all somehow related to celebrities and stuff like that. So they are connected. You can have many of these, and you can have a graph structure full of such descriptions, but you wouldn't be able to make many to derive many insights from it because you lack context. You wouldn't be able to derive any insights about when people are buying sports shoes and what kind of people prefer shoes in cold colors, just because you don't have this information in this graph. You only have colors like indigo and bright crimson, which are strings, and they will remain being strings before unless they're put in what you have in the middle here, a color taxonomy telling you that actually indigo is a kind of blue and that's a cold color, and bright crimson is orange and that's kind of warm color, and a few other things, so that you can derive all these insights about your own data. At the end of the day, it's the same product catalog of a retail store, but now enriched with more ontologies and taxonomies. That's precisely the context and the extra knowledge that allows much deeper analytics. And if you have a semantic graph database, you can also run inference, and this allows you to essentially make much quicker queries and slicing and dicing across graphs that have this extra context. So that's the high level offering, a high level proposition of knowledge graphs, and that's what we believe. What are the fundamentals, or like the basic requirements for such an enterprise-wide graph platform? Now, what this platform should look like? Well, at some point, one should make a technology choice whether and so far it was always the question: should I use the RDF technology stack or labeled property graphs, and which way to go? The truth is that they are to some extent isomorphic. So all the labeled property graph can easily be transformed into RDF, as you can see on this diagram. And then each of these models has its advantages and disadvantages compared to the task. So overall, RDF is much finer grained and allows for better data governance and more flexibility. But there are also use cases where the labeled property graph shines, and the model is proven to be more efficient for some kind of graph analytics forms. So there is nothing new. Essentially, the distribution of use cases between use cases that are served best by RDF and LPG is quite well known for several years. So the only new thing probably is that now, just recently, people came to the realization that if I want to have an enterprise-wide graph platform that serves all these use cases, within this platform, I need to have both RDF support and LPG. So it's not either or, it is plus. You need to have both, one way or another. And that's precisely the topic of our APAC manager, Brandon Richards. That's going to be the keynote on Thursday, right? So you go there and you can have a deep dive into this. He knows this story very well because he was APAC manager for U4J before. Now, this is a simple diagram, which over time will get a little bit more complex to give you really some sort of an outline of an enterprise-wide graph platform. It should support two major use cases. Semantic Knowledge Hub being the pattern, the name of the pattern of how you use knowledge graphs to deal better with documents and unstructured data, so that you can, at the end of the day, do better job in finding relevant documents and searching them, recommending, and everything else. And on the other hand, you have the data fabric pattern, which is all about providing better interface and better unified access across multiple different databases. Precisely the SeaWorld data problem that we discussed earlier. So the ultimate goal there is to be able to query these diverse databases as if they were one and the same. What is in common between these patterns is that in both cases they use metadata, semantic metadata, which describes the documents or the data sources with respect to a unified conceptual model, be it ontologies or data schemata or taxonomies or other kind of domain knowledge that is necessary to properly describe, so that you can easily discover and use all sorts of data and knowledge and documents that you have in this enterprise. So what is needed to implement this? Well, obviously, the question is who needs it? Well, there are plenty of applications that are very, very happy to use such unified data access if there is one. And BI tools can do much better work this way. And of course, such an unified view across diverse data, and also the access to those sorts of unstructured information and documents. This is a very, very useful and very, very beneficial for any other type of data analytics, downstream analytics that one may want to run. So these are the users, these are the consumers of this knowledge graph. Now let's see what is needed to implement such a graph. To properly implement the semantic knowledge graph hub, you need essentially knowledge management tools and text analysis tools. So all the way from building and refining taxonomies and adopting existing ones for the sake of categorizing documents and analyzing documents. And yeah, that's what these tools do. They essentially sift through these documents and generate metadata, and okay, they store this metadata, semantic metadata, in the knowledge graph. On the other hand, to implement the data fabric pattern, you need data management tools, essentially for data integration and quality, data quality, and data governance. Again, what these tools do is they analyze the separate databases and create metadata that describes these different data sources, so that you can query them as if they were one and the same. Doesn't matter whether virtualization or used or another data integration pattern. So yeah, this is as far as like the new tools that are needed to implement this vision. But it would be unpractical not to use metadata that's already there. And the truth is that in systems like office automation platforms, the systems like SharePoint or Google Suite, there is plenty of metadata already available. It would be a shame not to extract it and use it. And this should be part of a well-designed of the knowledge hub. On the other hand, most of the big organizations already have even not one but multiple data catalogs, which already describe these different data assets. So the only thing you need to do is to map them to this conceptual model to make it easier to integrate the data on the basis of these data catalogs. So a lot of metadata is already there. We must learn to use it. And now what we need as underlying engines and tools to implement this. On the one hand, for text analysis, in the last 10, 15, 20 years, you need a lot of machine learning tools and LLMs and transformers and other tools so that you can efficiently analyze documents, extract information from them, and categorize, and so on and so forth. On the other hand, if you're doing this well, you end up with big volumes of document metadata, and you need to store them somewhere. This is what document stores are all about. In each such design, there is a need for, apart from doing Sparkle queries, whether it's Cypher or Sparkle or something else, you need to be able to retrieve similar entities and similar documents. And that's everything that full text search engines are about, and nowadays everything that vector databases are about. And it's funny that vectors were always part of the search engines, but it's only now because of LLMs people started talking about it. Anyway, the last important piece of this picture is that because it is a graph, and sometimes you want to do really complex graph analytics on it, you need a labeled property graph engine, which is optimized for many of these tasks. So such an engine can take the data from the knowledge graph to benefit from the fact that you already have the unified view and you don't need data cleaning and integration. And then once whatever analytic job is done, it can push back, it can publish or share the results back to the enterprise knowledge graph to make them easier to discover and reuse for future projects. So yeah, that's the full picture. And I bet you have seen many of these pictures. Part of the story is what are the tough elements? What are the choke points? What makes it really hard to make such platform work? And here we can share what our view is. But to start with, you need a database engine that offers predictable performance across multiple key workloads. So it's all the way from being able to enforce semantics, do inference, to do data validation, to guarantee data quality, to be capable to manage metadata and data, and to share it based on some widely adopted standards. You need the graph analytics capabilities, of course, and nowadays you need more and more large language models and vector database integration to be able to properly interact with the new AI tools. At the end, you need such an engine that can put all these different query models and retrieval models together to combine structured queries with search with what you get out from the vector database. So that's what you need, and we're doing our best to implement this. You can get more details about it in Vasiu's presentation, which is just after mine, our CTO, Vasiu Monchev. On the text analysis side, you need essentially an ecosystem that allows you to experiment with different models and services, including LLMs, to find the best one, to measure the accuracy of these services and models, and what's most important, once delivered in production, to maintain and to manage the quality of the results of such pipelines. And of course, because it's all about doing something with information extracted from text doing something in the context of a knowledge graph, you need to be able to link the entities and the concepts mentioned in these documents to the right concepts in a knowledge graph, and we call this entity linking. So a few references on how we've been able to deal with these choke points. GraphDB is the first database engine who was able to pass both the social network benchmark and the semantic publishing benchmark of the Linked Data Benchmarking Council. So this is representative for the two workloads. So social network benchmark is about graph analytics. Semantic publishing benchmark is about semantic metadata management. And there is no other engine on earth which can do both and which has audited results. Luckily, we've been able to get to this point with GraphDB. You can learn more about LDBC, what is the Linked Data Benchmarking Council, from the presentation of its co-chair, Mr. Alistair Green, who is speaking in about an hour from now. Now, touching quickly on the enterprise content analytics side and text analysis side, our central offering there is the Ontotext Metadata Studio. It integrates with GraphDB and some other products of ours. Integrates with the knowledge management tools of our partners, and it offers out-of-the-box ready integration with many annotation services, text analysis services. If you want to learn more about it, attend the GraphDB graph building with text analytics session from Ivail Kabakov and Borislav Ankov tomorrow. Now, last bits on this. I mentioned linked entities being one of the most complex problem in this space. So when you have a text and you have Paris mentioned in there, the classic example of being able to disambiguate, to figure out whether this is Paris in France or Paris in Texas or Paris Hilton. That's a tough problem, and we've been working on it for some 20 years. We've been demoing how we solve this problem on top of big graphs like Wikipedia and Wikidata and company data graphs. So it was all around, but we did this in a sort of very custom way, very boutique way, very also expensive way, with a very tailor-made model and pipeline. What we did over the last year is that we put a lot of research to see how we can make this better and to better serve different contexts and to make it really quick and cost efficient to implement it in customer projects. So now we have 4 new separate entity linking models, depending on whether you need a general one, whether you want to work with Wikidata, with your proprietary data, whether you are eventually in the biomedical domain, whether it should be multilingual or not. Quite a few of those are based on XOM Robert, but we experiment with Roberta, but we experiment also with other tools, and all the time playing also with ChatGPT in different functions, be it for named entity recognition or something else. So that's this was really tough, but now we are ready to offer the most efficient one for you. Finally, on top of all this experimentation, we have a demonstrative knowledge graph with ChatGPT integrated. That's a question answering demo, which will be delivered by Krasimira Bojanova-Krasi on Thursday. So with this, I want to wrap it up. Where shall an enterprise start with? If you are a big enterprise, you better start with implementing a data fabric while choosing choosing carefully what are the first use cases to start with. If you are a small medium enterprise, most likely the knowledge hub pattern of giving you access to your unstructured documents is more important for you. And then we have different offerings for the different domains. So thank you very much for your attention and enjoy the Knowledge Graph Forum 2023. Thank you.